This is Professor Pelton. This is Algebra 2, Chapter 7, Section 2 on graphing rational functions. Now that we've learned how to find slant asymptotes, horizontal asymptotes, vertical asymptotes, and holes, now we can graph all the different variations of rational functions, which there are three. Either the numerator is larger than the denominator as far as the leading power, the denominator is larger, or they're the same. Those are your three scenarios that play out in the graphs. Okay, so for our first problem here, we have the denominator larger than the numerator as far as the problem. So let's go through the process of graphing this function. Okay, so as far as the y-intercept goes, by definition, x must be 0 for all y-intercepts. So if I take the function and I plug in 0, I get y equals 1 over 0 minus 2 squared, or 1 over 4. So 0, 1/4 is the y-intercept for this particular graph. So estimate a point approximately right there. It's a little off, but that's fine. Okay, so for the x-intercept, by definition, you must be 0 for the y. Okay, so we'll plug in 0 for y, and I get 0 equals 1 over x minus 2 squared. Okay, so I want to cross multiply here, so I'm going to make that 0 into a fraction and cross multiply this way and get a 0, cross multiply that way and get a 1. But wait a minute, 0 doesn't equal 1. That means there is no, not applicable, there is no x-intercept here. Okay, vertical asymptotes and holes. So if you look at the denominator and the numerator, they have nothing in common. So nothing cancels. Therefore, there is no hole. But x minus 2 cannot equal 0. You don't really need to do squared because essentially this is 1 over x minus 2 times x minus 2. So you don't really need to do it twice. Okay. So therefore, x cannot equal 2. So that is the vertical asymptote. And there is no hole because nothing canceled. Okay. A little sloppy, but it's there. Again, it must be dotted because it's an invisible line. So horizontal asymptote, we'll plug in infinity. So we get y equals 1 over infinity minus 2 squared. Okay, so this is a scenario where the bottom is larger. So 1 over, so if you think about it, infinity minus 2 is infinity. It doesn't make much of a difference. If I square infinity, I still get infinity. Okay. Either way, I'm taking 1 and dividing up in infinite times, which means there's nothing left over. You get 0. Okay. So if there is a horizontal asymptote, there is no slant asymptote. You can have one or the other. You can have both holes and verticals, but not horizontal and slant. So we have a dotted line that goes this way, and you get y equals 0 here. Okay, so at this point, it's a matter of filling in the graph. So either you're going to have something up here or something down here, but not both because it would not pass the vertical line test. Okay. Okay, since I know the point is up here, I know it's going to go like this. It's going to go through that point and then follow these because it can't cross, and it's going to follow them, the asymptotes. So the other question is it going to be up here or is it going to be down here for the right-hand side? It cannot be both because it wouldn't pass the vertical line test. It would not be a function. So it has to be one or the other. Since I have no distinguishing points to tell where it is, I have to pick something over here to plug it in. Since the vertical asymptote is at 2, I'm going to pick any number greater than 2, because any number greater than 2 would be past the vertical asymptote. So I'll pick 3 and plug it in. So y equals 1 over 3 minus 2 squared. So that gives me 1 over 1 squared, or just 1 when I simplify. So basically I get a coordinate If I plugged in 3 for x, I get a 1. So I get 3, 1 as a coordinate. So 1, 2, 3, 1 is a coordinate. Okay. So which means it's going to go like this. Right? And follow it. Okay. Follow the asymptotes. All right. So let's check on the calculator, make sure that's actually true. So I have 1 divided by x minus 2 squared. And there we go. That is the correct graph. Okay, so this is the first scenario where the denominator is bigger than the numerator. Okay, let's look at the next scenario. In this scenario, the numerator and denominator are of equal powers. Okay, so the process is the same each time, regardless of what type of rational function it is. So again, y-intercept by definition, x must be 0, right? Because it's on the y-axis, x must be 0. So y equals 3 times 0 squared over 0 squared minus 4. That equals 0 over negative 4, which is just 0. So we know that is our y-intercept. X-intercept by definition, so if it's on the x-axis, y must be 0. So 0 equals 3x squared over x squared minus 4. I want to cross multiply, so I'm going to put a 1 on bottom so I can do that. So this way gives me 0. This way gives me 3x squared. So if I divide by 3x squared is 0, and I square root, I still get 0, which makes sense that the origin is both an x-intercept and a y-intercept. Okay, vertical asymptotes. The numerator and the denominator have nothing in common. Therefore, there are no holes. But x squared minus 4 cannot be 0. Okay? So x squared cannot be 4. Or if I square root, x cannot equal plus or minus 2. So x equal to 2 and x equal to negative 2 are the vertical asymptotes. Again, nothing canceled on the top and bottom, so there's no holes. So 2 and negative 2. Okay, so let's see. Next thing is horizontal asymptote. So we'll plug in our infinity. So y equals 3 times infinity squared over infinity squared. I'm not going to do the minus 4 because only the leading terms matter. So I really have this. The infinity squareds cancel, leave me with 3 over 1, which is essentially 3. So I get y equals 3 is my horizontal asymptote. Okay. All right, so there's a horizontal asymptote. That means there cannot be a slant asymptote. All right, so at this point, I know that this one has to go down, and there cannot be anything up here. That's not possible because it wouldn't pass the vertical line test. Plus, it's not going to cross the asymptotes. And you can do values if you want. So you could plug in 1 or negative 1. So if I plug those in, I'd get y equals 3 times 1 squared over 1 squared minus 4, which would give me y equals 3 over negative 3, which is negative 1. So we get essentially that. And if you plugged in negative 1, it wouldn't make any difference because you're squaring them. So you would still get that right there. So I'm a little off on my graph, but the general correct direction. So in the next question basically is, am I up here or down here? Am I up here or am I down here? You got to be one or the other because you need to pass the vertical line test because you're a function. One input gives you one output. Okay. All right, so we need to pick something in those areas. So I need to pick something greater than 2 or less than -2. So if I pick greater than 2, well, pick 3. So y equals 3 times 3 squared over 3 squared minus 4. So if I do out the math, that's going to be what? Y equals 3 times 9 over 9 minus 4, which gives us a 27 over 5. So 27 over 5 is 5 2/5. So 1, 2, 3, 4, 5 2/5 is right there. So essentially I plugged in 3 and I get 5 2/5. If I plugged in -3, would it make any difference? Well, no, because the negative is being squared. You still get the same answer. So at -3, you would get the same answer. 1, 2, 3, 4, 5 2/5, which means it must be up here for the actual function. Okay. All right, let's verify that with the graphing calculator. So the top gives me 3x squared, and the bottom, x squared minus 4. And there we go, right? You can see our horizontal asymptote there, and our two verticals here, right where we thought they should be, and our intercept at 0, 0. Okay, so C, the last scenario. Again, all three scenarios are done the same. This scenario, the numerator has a higher power than the denominator. Okay, so by definition of y-intercept, x must be 0. So we'll plug in 0 for x, and I get y equals 0 squared plus 1 over 0 minus 1, which is 1 over -1, which is essentially just -1. So at 0, -1, I get my intercept. There we go. Okay, x-intercept by definition, y must be 0. So I get 0 equals, come on, x squared plus 1 over x minus 1. And I want to cross multiply, so I'm going to make that a fraction. So I cross multiply this way, I get 0. And I cross multiply this way, I get x squared minus plus 1. So if I minus 1, I get -1 equals x squared. But if I square root that, I get x equals plus or minus I, which means there are no x-intercepts here. Okay, so vertical asymptotes and holes. Nothing cancels with the numerator and denominator, so there are no holes. Because x squared plus 1 does not cancel. X minus 1 in the denominator cannot be 0, therefore x cannot be 1. Therefore x equals 1 is the vertical asymptote. So we'll put the vertical asymptote in there. X equals 1. And then the horizontal asymptote, if I plug in infinity, y equals infinity squared plus 1 and infinity minus 1. Again, the non-leading terms don't really matter. So essentially I have 2 infinities over 1 infinity, which just leaves me with infinity, which means there is no horizontal because it's going to infinity along a line which is slanted. So we have to do long division. So x minus 1 into x squared plus 0x plus 1 for our division of the problem. Okay, so x is the first factor. So minus 1x, and I multiply. So that gives me 1x plus 1 Whoops. Whoops. Okay, so the last one is just a +1, so that gives me 1x and -1. So if I subtract, I get a remainder of 2, right? Because 1 minus -1 is 2. So I get +2 over x minus 1. But the remainder of 2 over x minus 1 doesn't matter, because if you plug in infinity, which is what's happening horizontally, you get 2 over infinity, which is nothing. So essentially I get y equals x plus 1 is my slant asymptote, which has a y-intercept of 1 and a slope of 1 over 1. So we're going to follow that line there, right? Because you have the y-intercept of 1, up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. Okay? But again, it's a dotted line. There's no actual values there. It's just boundaries we cannot cross for our slant asymptote. Okay? Right? Slant asymptote, slope of 1, intercept of 1. All right, so I know from the point given that this must follow this line and this must follow this line. So the only question now is, am I in this triangle or am I in this area down here? I have to be one or the other. I cannot be both because I will not pass the vertical line test. Okay, so let's see here. So I should pick a point in that region. So basically something greater than 1, since that was our break point between the two sides. So something greater than 1. So I'll plug in 2. So y equals 2 squared plus 1 over 2 minus 1. So y equals 4 plus 1 over 1. So therefore y equals 5. So I plugged in 2 and I got 5. So 1, 2, 1, 2, 3, 4, 5, which means I'm in this upper region up here, which means that is our final graph with a slant asymptote and a vertical asymptote, but no horizontal. Okay, let's take a look at what that looks like on the calculator and verify we did it actually correctly. So we'll start a new one here. So the numerator was x squared plus 1, and the denominator was x minus 1. Okay, look at that. We got the slant going this way, and we have the vertical going this way as we had thought, and they're invisible. Okay, pause the video. Try these student problems for yourself. Okay, student problem. By definition, if you're a y-intercept, x must be 0. So if we plug that in, we get y equals 0 over 0 squared minus 4, which is 0 over -4, which is just 0. So that is our first point. Okay, so next one, x-intercept, by definition, your y must be 0. So y equals, I'm sorry, that's wrong. Y was 0. I just said that. It's x-intercept. 0 equals x over x squared minus 4. I'll do that over 1 so I can cross multiply. So this way I get x, and this way I get 0 when I multiply, which makes sense. An x-intercept and a y-intercept are the origin. Okay. Vertical asymptotes and holes. Since the numerator and denominator has nothing to cancel, there can be no holes here. However, x squared minus 4 cannot be 0, so x squared cannot be 4. So if I square root both of those sides, x cannot be plus or minus 2 when I square root the 4. So y equals 2. I'm sorry, how did I write y? That's x. X equals 2 and x equals -2 are my vertical asymptotes. X equals -2, x equals 2. Okay, good. All right, horizontal asymptotes versus slant asymptotes. We'll plug in infinity. So y equals infinity over infinity squared minus 4. Again, non-leading terms don't matter. So essentially I have infinity over two infinities, which leaves me with 1 over infinity, just like x over x squared. Just one of them cancels. So essentially 1 divided up infinite times, right? You get nothing. So y equals nothing is the horizontal asymptote, which means there is no slant asymptote. So y equals 0. All right, and you're wondering why there's a point on the horizontal asymptote. You can have points in the horizontal asymptotes. That's just the behavior as it goes to infinity and negative infinity. That's not the local behavior. The vertical asymptotes are things you cannot be. Okay? Notice how we solve them. One is cannot be, which is vertical and holes, and the horizontal and slant is just the general direction it goes for infinity. Okay, so the question is what's going to happen? So we should plug some values in here to see what's going to happen. So I'm going to plug in 1 and negative 1. So y equals, if I plug in 1, I get 1 over 1 squared minus 4, which gives us 1 over negative 3. Okay, so it's about right there, which means it's going down like that. If I plug in negative 1, what's going to happen? If I plug in negative 1, that goes negative. That's going to stay positive because it's squaring it. So essentially I get positive 1/3. So I'm on this side. So it's going to go that way for that one. Okay, so on the other two sections, we need something greater than 2 and less than negative 2. So we'll just do 3 and negative 3. So y equals 3 over 3 squared minus 4. Is this 3 over 9 minus 4? Or what is that, 3/5? Yeah. Okay, so that's a positive value. So I go over to 3 and I go up to 3/5, which is about right there. So that just tells me that it goes like this and like this. It's supposed to slope down towards it. Sorry. All right, on the other side, how about negative 3? Well, if I do negative 3, that goes negative. That's negative, but I'm squaring it so it stays positive. So that stays negative. So it's just going to be negative 3/5 on the other side. So at negative 3, it's at negative 3/5. So essentially, it's down there like that. Okay, let's go to student problem B. So in this scenario, they are of equal power, top and bottom. Let's see, y-intercept by definition. X is 0, so we have y equals, 2 times 0 squared. I didn't write that very well. 2 times 0 squared over 0 squared minus 9. So essentially 0 over minus 9, which is 0 for x-intercepts. Y is 0, so 0 equals 2x squared over x squared minus 9. We'll put it over 1 so we can cross multiply. So we get 0 this way, and 1 times 2x squared is 2x squared. So if I divide by 2, I get x squared is 0, or x essentially is just 0, which makes sense to the picture here. Okay. All right, next piece, vertical asymptotes. The numerator and denominator have nothing in common, but x squared minus 9 cannot be 0, so x squared cannot be 9. So if I square root both sides, x cannot be plus or minus 3. So x equals 3 and x equals negative 3 are the vertical asymptotes, and there are no holes since nothing canceled. So we have x equals 3 and x equals negative 3 as our vertical asymptotes. All right, horizontal asymptotes. We plug in infinity. So y equals 2 times infinity squared over infinity squared minus 9. Again, non-trailing terms don't matter. So I essentially have 2 times infinity squared over 1 times infinity squared. And those cancel because they're like, just like x squared over x squared. So I get y equals 2 over 1, or just 2. So since there is a horizontal, there cannot be a slant. It's one or the other in those cases. Holes and verticals, they can be both or neither, or one or the other, but slant and horizontal is one or the other. All right, so y equals 2. Okay, so in this case, you can plug in some values if you want. We know since it's at 0, 0, it's in the bottom portion. If you plug in 1 or negative 1, it's 2 times 1 squared over 1 squared minus 9, which essentially gives us 2 over 1 minus 9, or 2 over negative 8, right? So essentially, you know it's going to be a negative 1/4. So if you plug in a negative 1, it makes no difference because the squared makes it positive. So you get the same answer. So either way, you're going to get parabolas that go like this. So the trick now is you can do more values if you want, but the question is it up here or is it down there? And on both sides, you should know without doing any work whatsoever, because there's a trick. There are no more x-intercepts other than 0, 0. So since there is no more x-intercepts, you cannot be in the bottom. You must be in the top. So your graph is essentially on the top on this side and the top on this side as a result. Okay? All right, let's try problem C. So in this case, the numerator is larger than the denominator as far as the power. By definition of a y-intercept, x is 0. So y equals 0 squared minus 4 times 0 minus 5 over 0 minus 3. So I get negative 5 over negative 3. Hence 5/3. Okay, so that's 1 2/3, right? All right, so we'll go to 1 2/3. We'll put a dot right there. That seems good. All right, X-intercepts. Well, that means y is 0 by definition. So if I do that, 0 equals x squared minus 4x minus 5 over x minus 3, because y is 0. I'm going to put over 1 so I can cross multiply. So that way gives me a 0. In that way, 1 times a polynomial is x squared minus 4x minus 5. Okay, so that is factorable, I believe, because I'm going to get 1x, and factors of 5, since 5 is prime, is only 1 and 5, and negative 5 and positive 1, multiply with negative 5 and add to negative 4. So x plus 1 cannot is equal to 0, and x minus 5 is equal to 0. So x is negative 1 and x is 5, okay? Which means we have 2 of these x-intercepts. So 1, 2, 3, 4, 5 right there, and negative 1 right there. Okay, it's an odd graph so far. So let's try our vertical asymptotes. The numerator and denominator have no factors in common, because as you see, as when we factored this, that was what, x plus 1 and x minus 5, so had nothing in common. Therefore, there are no holes. But the x minus 3 cannot be 0, so therefore x cannot be 3. So our vertical line of x equals 3, which means that right-hand point does not connect to the 2 left-hand points that we have so far. So horizontal versus slant. We're going to have one or the other. So again, only the leading terms matter. So if I plug it in infinity, so that's y equals infinity squared minus 4 times infinity minus 5 over infinity minus 3. So again, the non-leading terms don't matter. So essentially I'm left with infinity squared over infinity to the first, which is essentially infinity. So that means there is no horizontal asymptote because it's going up to infinity in a slanted manner. So I have to do long division. So x minus 3 into x squared minus 4x minus 5. So first multiple is x. That gives me x squared minus 3x. So that gives me negative 1x minus 5 when I subtract. The next multiple is negative 1. So that's negative 1x plus 3. So that gives me a negative 8. Yes. So plus negative 8 over the x minus 3, which is irrelevant because when you go to infinity, the negative 8 gets erased by the denominator of infinity. So essentially I have a slant of y equals x minus 1. So that's a y-intercept of negative 1, essentially, and a slope of 1, so up 1 over 1, right? So this, did I miss that? I did miss a little bit. Okay, a little sloppy, but we got it in there. So it's just in, this need to be in there. Okay, so there is our slant asymptote, which isn't the greatest, but I think I got it in there. Okay, so I can tell from our points that we got that this is going to go up like this and follow the line like this. And since I have a point over here, it's going to follow up here and go down here. Okay, so I was a little off on this area here, but a little sloppy. We can verify with the calculator. Cancel, no. Oop. So let's see, the numerator was x squared minus 4x minus 5 divided by the x minus 3. Right, there we go. That's what we had, right? Vertical asymptote at x is 3 right here, and we have a slant goes right through the negative 1 at a 1 over 1 slope there. All right, that is the end of this section.